Hello, this is number 7 on the practice final. It deals with sampling. We're given y of t, which is equal to x1 of t times x2 of t. Y of t is going to be sampled by a periodic impulse train. We know that x1 of t is band limited to 500 pi, and x2 of t is band limited to 1k pi. We're asked to find the Nyquist rate of the signal y of t. So the first thing we want to do is think about y of t as a function of frequency. So by what we've learned so far, we know we can think about functions in the frequency domain by using the Fourier transform. So we have y of t, so let's find x1 and x2 of t in the frequency domain. We're just doing this symbolically, really. And I'm just gonna write it like this. This arrow and little f means we're mapping from the time domain to the frequency domain where the Fourier transform exists. So we know from the problem statement that x1 of t is band limited, so that means be above 500 pi, and x2, same deal, we've been given the limit. So we know that we want to find the Fourier transform of y because the signal asks us for the Nyquist rate of y of t, not x1 over x2 of t. So we know y of t is equal to x1 of t times x2 of t. If we take the Fourier transform of y of t, multiplication in the time domain is equal to convolution multiplied by some scalar, in this case 1 over 2 pi in the frequency domain. This factor 1 over 2 pi, we haven't really talked about it in this class, but if you ever go on to study complex analysis, you'll see this little scaling factor is quite important and shows up in everything, and it's really a kind of interesting part of complex analysis, and a lot of people have spent a lot of time thinking about why, like Cauchy, etc. But anyway, so yj omega is equal to something. We don't need to worry about what it is, but we do know that it's going to be equal to 0 for its band limit, and this is just a direct consequence of convolution. So 1500 pi. So we know that the maximum omega is 1500. The Nyquist rate is defined just as 2 times omega m, so 3k pi. Okay, that's it. That's number 7.